So a reciprocal, if I gave you the fraction 2/3, let's say, the reciprocal to that would be what? Does anyone know? Any random guess? Yes, it would be. The reciprocal would be 3/2. It flips. The reason why it flips is you put 1 over it. So say we had a 3. The reciprocal would be 1 over 3. So you're literally just doing 1 divided by it, correct? So why does 2/3 turn to 3/2 then? Well, to get 3/2, if I did 1 divided by 2/3, I would write it sideways, remember? Because whenever I have a fraction, I write it sideways so I can flip that baby. So that would be the same as 1 times 3/2, which is actually 3/2. So reciprocal means 1 divided by whatever the heck you have. That's what reciprocal means. 1 divided by whatever the heck you have. So when we did reciprocals of fractions, we would just flip them. But the reason why we flipped them is it was 1 divided by that number, which causes it to flip. Right? So when we divide by something, we flip and multiply. So what we're going to look at instead of numbers is we're going to look at reciprocal functions. Great times. So the functions of grade 11 that we deal with are linear from grade 10, so like x plus 2, 2x minus 1, and quadratics, x squared plus whatever. So what we're going to do when we find the reciprocal of something is we're going to do 1 over that function. So 1 over a linear function, or 1 over a quadratic function. Okay? So let's look at this one. This is our parent function. So we have complete the table for the values of x and y equals x. So this is going to be just our x, and then the equation we're going to do is y equals x. So type this into your calculator. Y equals x. You'll see why finding the number or the value isn't that hard. But so you get a straight line because wherever your y is the same as your x, you would draw a coordinate, correct? So it'd be 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. It makes a horizontal line. It's actually called the identity line. So when x equals 1, y would equal x, so 1. When x equals 2, y would equal 2. When x equals 3, y would equal 3. If we do in the reverse order, if x equals -1, y would equal -1. If x equals -2, y would equal -2. -3, -3, -4, 4, 0, -4 and -4. 0 and 0, right? So if I sketch the line y equals x, it's going to be in blue. It's going to be 0, 0, 1, 1, 2, 2, 3, 3. Every decimal in between, that's the same as well, right? So like 1.5 and 1.5, that would also be on here, correct? All the ones where the x's and y's are the same. -1, -1, -2, -2, -3, -4. So this is actually called the identity line. We're going to deal with it for inverses next year, for reflections next year. But for now, it's just the line y equals x. Okay? When we do the reciprocal of the line y equals x, we just take the function x and we put it under the number 1. That's all we're doing for reciprocals. 1 over x. So if I do 1 over x to get my y, we're going to ignore this line here, because this line here correlates to the y's of the y equals x line, right? We're going to do the y's of 1 over x. So if x is 1, my y is going to be 1 over 1, which is 1. So did the point change? I should do this in a different color. 1 over 1, which is 1. Did my coordinate change? No. I'm going to sneeze. Excuse me. Thank you. And then instead of it being 2, it's going to be 2 and then 1 over 2. which is 2.5. So I'm going to go to 2 and 0.5 and plot it out. And then instead of 3, 3, it's now going to be 3 and 1 over 3. So 3 1/3. That's like 0.3333. Now what if I do -1? Instead of being -1 and -1, it's going to be -1 and 1 over -1, which is -1. So it actually stays the same there. -2 becomes 1 over -2, or -0.5. So now I'm at -2 and -0.5. -3 becomes 1 over -3. So my new coordinates at -3 and -1/3. Because these are my x's, these are my new y's. I'm I'm ignoring this middle column, right? So -3 and -1/3. And this one's going to be -4 and 1 over -4. So -4 and -1/4. That's getting awfully close to the x-axis. And then 0 is 1 over 0. Uh-oh. Can I divide by 0? No. This would be undefined. And what we're going to learn about undefined is you get an asymptote there. It's a cool word. So if your y is undefined, your x equals 0 is going to be an asymptote. And to actually be more clear, it's going to be a vertical asymptote. And why is it vertical? Because whenever I draw x equals lines, they cross through the x-axis, which makes you have a vertical tick, and then the line would go vertically. Any x equals line is actually a vertical line. Any y equals line is a horizontal line, right? So if I said y equals 2, right here, at y equals 2, I would draw the horizontal line, correct? So all y equals lines are horizontal. X equals line, I'm going to end up with a dashed line. This is what an asymptote looks like, a dashed line on x equals 0. This is going to be x equals 0, and it's an asymptote. So it's a dashed line because it doesn't exist. Now, whenever we have 1 over x, like that, 1 over x, we're always going to have a horizontal asymptote at y equals 0. So whenever our numerator is a smaller degree than our denominator, or just a constant, we're always going to end up with y equals 0. Now, I pretend that this is like cattle walking along a fence. So those little dashed lines are electric fence that cows cannot walk across. If you've never met a cow, this is what they do. Hello, cow. So we start at this dot here, I'm going to start at, and then the cow's walking along and they're like, there must be more grass on that side. And then they see the electric fence and they're like, I'm just going to keep walking along here and I'm going to hope that eventually the fence will stop. But it doesn't, and you just ride along it, the cow does, right? And then the cow's like, oh, that way didn't work. So then the cow's like, okay, I'm going to try this way. So then they ride along the fence, and then what happens? They're like, I'm going to keep walking along here in hopes that there's a break. And I'm probably going to try and stick my head through and eat the grass in the ditch. That's what a cow's going to do. It's real. So there's my cow on that side. And then I have a cow on in the other pasture, yonder, across the way. There's always, for reciprocal graphs, your cows are always in opposite pastures, diagonal from each other. So if the graph had started up in the top left, it's going to end in the bottom right, because your cattle will be opposite. So this cow's like, dude, I think I might have some, sir. You might suck down here in this quadrant, but in quadrant 1, I'm good. I'm going to walk along it, and oh crap, this is the same as that one. And the cow keeps going. And then the cow's like, dude, maybe I'm going to try this way, because you suck over here in quadrant 3. Maybe the cow, and they're just right along here, and there's no breaks. Okay, and boom, when the cows are done walking, you have a reciprocal graph. Isn't that fun? Let the cows walk. Boom, reciprocal graph. Okay, so type into your calculator y equals 1 over x. And you're going to see differences depending on which calculator you have. So if you type y equals 1 over x into your calculator and you press graph, if you have the TI-83s and above, you're going to get a graph that curves here and a graph that curves here, and you won't be able to see the asymptotes. They won't be drawn, right? It's just a curving graph and a curving graph. If you have the TI-83s, the TI-83 calculators were of the times where the calculator believes all functions must be continuous. This is not a continuous graph, because this cow walks, and then there's a break, and then the new other cow would walk, right? There's a break at x equals 0. At x equals 0, there are no values, correct? We have a dashed line. With the TI-83 calculators, it's like must be continuous. So when it draws it, it goes like this. And then instead of stopping and drawing it not continuous, it goes must be continuous. And then it connects it and draws here. So you see this connection in between on the TI-83s? This connection doesn't actually exist. That's an asymptote. So when you draw the graph, you have to draw it with breaks like this graph is drawn, or like I drew, correct? You can draw your asymptotes as dashed lines, that's fine. But you do not sketch this graph that you see that looks like a heart rate monitor on your TI-83 graphs, because your calculator is trying to make a continuous graph that's not continuous. So it sketches it, and then it's like, it must be continuous, and then it sketches it again, right? So on the TI-83s, you will see it trying to connect itself, but that's not real, okay? So don't draw like a heart rate monitor on your TI-83 onto a test, okay? Does this make sense so far, what we've done? Okay. Good. Now, where the original graph of y equals x has a 0, that's where y equals 0. So where it has an x-intercept, that's where y equals 0. The graph has an x-intercept. At that point, the reciprocal graph cannot be defined. So basically, whenever you have an x equals 0, when it's 1 over x, you're going to end up getting a 0 in your denominator, right? Which is a problem. So that's where your asymptote is going to be. Whatever creates your denominator, whatever gets you an NPV, basically, that's why we did rationals before this as well. Wherever your NPVs are is where you're going to have vertical asymptotes. So if in our denominator we had x plus 2, how would we solve that for NPVs? NPVs, we'd say x equals negative, or x can't equal negative 2, right? But where that NPV exists is now where we're going to end up with an asymptote when we don't draw the graph. Okay, which will come up. So we're going to put a definition of the asymptotes. So our asymptotes we have here, we have a vertical asymptote. Our vertical asymptotes are always x equals asymptotes because x equals lines are vertical. Okay, so our vertical asymptote of this graph is where it doesn't exist, which is the NPV of this graph. And if we look, the graph equation, it was y equals 1 over x, wasn't it? If I went back to the rational unit, what would my non-permissible value be if I just had an x in the denominator? My NPV would be x cannot equal 0. I would just set x not equal to 0, right? And I'd be done. So my NPV is actually my vertical asymptote. So it would be x equals 0, because it's where the graph exists, or it's where that asymptote exists, which means it's where the graph doesn't exist. So it's x equals. My horizontal asymptote, if my numerator is a number and my denominator has a variable, my horizontal asymptote will always be at y equals 0. So because this numerator was a number and this denominator was a variable or a letter, we are going to get y equals 0 every single time. It doesn't change. So if your numerator is a number and your denominator has a letter in it, it's y equals 0. It's the easiest one to find, horizontal. Domain and range are ridiculously easy if you can find the asymptotes, because it's just where those are not. So, for example, my domain is going to be x such that x cannot equal 0. And I'll explain it. XER. So my asymptote was at 0, correct? So that's where the graph does not exist. We agree? So if I say x such that x can't equal 0, but it equals everything else, that covers this graph. Because if you look at the red graph, I have from negative infinity all the way to 0 curves, right? And then from 0 all the way to positive infinity exists. The only place that doesn't exist is the asymptote. We agree? So the fastest way to write that is actually to say it can't equal 0. That's it. Before you leave this year, I'm going to reiterate interval notation to you, because you have to know interval notation going to dash 1. But you don't do interval notation if you go into dash. This is set theory. This is set notation. This is expected in dash 2. In dash 1, you have to know set notation and interval notation. Now the range. This graph exists everywhere, every y except for what? If we look at our y's, where does this graph exist? Everywhere except for 0. So I can do all my negative y's to 0, and I can start above 0 all the way to my positive y's, correct? But the only place it doesn't exist is the asymptote. So it's going to be y such that y cannot equal 0, y-er. So your domain and range are only hard if you can't get your asymptotes. Because here, I got my asymptotes, x equals 0, y equals 0. My range is really easy. It's just not equal to them. That's it. That's all. Okay? So if you can get your asymptotes, domain and range are instantly found. If you can't get your domain and range. They go hand in hand. Now the other thing to note is invariant points do not change when a transformation is applied. So for a reciprocal function, invariant points are ones that do not change. They occur when f of x equals 1 and f of x equals negative 1, which is the same as saying y equals 1 and y equals negative 1. Why do those points not change when y equals 1 and y equals negative 1? How do we find our new points? Our new y values? How did we find our new y values up here? Our old we just plugged in. Our new we took these ones and divided them under 1, right? So for reciprocals, remember I told you that? You do 1 divided by whatever the heck y was. That's how you get a reciprocal. Well, which ones do the numbers not change? At 1 and negative 1, correct? Because at negative 1 here, I did 1 divided by negative 1 and it stayed negative 1. At positive 1 up here, I did 1 divided by 1, which equals 1. It doesn't change, right? Because when I do 1 divided by 1, it stays the same. When I do 1 divided by negative 1, it stays the same. But if I do 1 divided by any other number, they change. Like 1 divided by 4 is a quarter. 1 divided by 10 is a tenth. 1 divided by negative 3 is a negative a third, right? But 1 divided by 1 is 1. 1 divided by negative 1 is negative 1. They don't change, which means they remain invariant. So invariant points are ones that do not change. And for reciprocals, that's when y equals 1 and y equals negative 1. Because the reciprocal of 1 is 1 divided by 1, which is 1. The reciprocal of negative 1 is 1 divided by negative 1, which is negative 1. It does not change. And we're going to flip over. Okay, so we're going to consider another example. Y equals 1 over x minus 2. I don't actually have to graph this to get my asymptotes. My vertical asymptote is always a vertical line, and the vertical lines are always what equals lines? X or y? Vertical lines. X. And always think of it, it's always the opposite of your axis. So if your x-axis runs this way, x values are going to create vertical lines. If your y-axis runs this way, y-axis or y-equals equations are always going to give you horizontal lines. They're the opposite of the axis. Okay? So I'm going to go vertical asymptote first. Is vertical an x equals line or a y equals line? It's an x equals because it's always the opposite of the axis, right? So if it's a vertical axis is y equals, but vertical asymptotes, vertical lines are actually x equals line. Now, our vertical asymptote just comes from our non-permissible values, our NPVs. So if I get my NPVs, I will have my vertical asymptote. How do I get the NPV of 1 over x minus 2? X minus 2 is connected, so it's in brackets. So I put it in brackets. And how do I get non-permissible values? take what's in the bracket and I set it?
Equal to 0.
Yeah, equal to 0. Find out what it can't be. So I can go x minus 2 equals 0 or can't equal 0 if I want, because that would cause a problem, right? It would make my denominator be 0. So I have to find all the places where my denominator returned to 0 because that's an issue, right? Then what did I do? I added 2 over and I got x cannot equal 2 as my NPV, didn't I? That's how we did it. We added the 2 over. Just got my vertical asymptote. So x can't equal 2, correct? And asymptotes are where the graph does not exist. They're dashed lines, and it's where the graph can't be, right? It's the electric fence that the cow can't go to. The cow can walk along it, the cow can't touch it. It gets zapped, right? So it's where the graph does not exist. So if x can't equal 2, because it would cause me a denominator of 0, right? My vertical asymptote is where the graph doesn't exist. So it's at x equals 2. That's where my dashed line is going to be. Okay? Now what's my rule for horizontal asymptotes? If my numerator is a number and my denominator contains a variable, it's going to be at y equals what? 0. If my numerator is a number, my denominator is a variable, that means my numerator is a smaller degree than my denominator. Because my denominator is degree 1, it's x to the 1. And this one's technically x to the 0, because anything to the power of 0 is 1, right? So the degree of the numerator is smaller than the denominator. So if my numerator has no variable and my denominator has a variable, my horizontal asymptote's at y equals 0 every single time. It does not change. It's immediately easy. If my numerator is a number and my denominator has a variable, it's y equals 0. We're done. No work. That's it. Really easy. So for this one, let's state the domain and range just for extra. So the domain is x such that x cannot equal what? 2. It's just my asymptote. So once my asymptotes are done, my domain and range is really easy. And my range is y such that y cannot equal 0. Y here. So I want you to give me the vertical, the horizontal, and I want the domain and range, please, for this one. Vertical, horizontal, domain and range. Let's look at this one. The vertical asymptote is always the x or the y. It's the x because it's the opposite of the axis, right? The vertical axis is a y equals, so vertical asymptotes are x equals. So I take my denominator, my x plus 3, and I say x plus 3 cannot equal 0. X cannot equal negative 3. So my asymptote, is my asymptote not equal to or equal to? Not equal to is the domain. My asymptote is equal to, because it's where that asymptote exists. Think of it, it's where the dashed line is. So it is where the graph does not exist, that's true. So if I asked you, is the asymptote where the graph exists or doesn't exist, you'd say does not exist. But you have to put equal to, because that asymptote is the dashed line where the graph doesn't exist. So my vertical asymptote is x equals. And remember this, x equals negative 3. Remember that your asymptotes are equal to, your domain and range are not equal to. And it doesn't ever switch. Your asymptotes are equal to, your domain and range are not equal to. What's my horizontal asymptote at? Y equals 0. We need the y equals because an asymptote is an equation. If you just put 0, it won't work. We need y equals 0. Now why is it y equals 0? Because the numerator is degree 0 technically. It's a number, and my denominator is a variable. So my numerator is a smaller degree than my denominator when my number over variable happens. Okay? My domain is going to be x such that x cannot equal negative 3 xer. And my range is going to be y such that y cannot equal 0 yer. Now, you can always plug these in. So please type it into your calculator and see if that verifies what you see in front of your face. So type it into your calculator, y equals 1 over x plus 3. Make sure you put your x plus 3 in brackets. If you don't, or use alpha y equals enter. So if you have the new calculators, you're going to press y equals and go alpha y equals enter, and you get a fraction, and you type it in the fraction, right? If you have the older calculators, you're going to have to type it in as y equals 1 over x plus 3 in brackets. If you don't, your calculator, if you type it in like this, 1 divided by x plus 3, your calculator is going to read this in order of operations. So it's going to go 1 divided by x, graph that, and add 3. And that's not what you want, right? So if you have the older calculators, you need to put that x plus 3 in brackets because that's the only way your calculator knows fractions. You can even put the 1 in brackets. So for any calculator, if you want it to know that it's a fraction, you put numerator in brackets divided by denominator in brackets, and that's how it knows it's a fraction, if you want to guarantee a fraction. Or through the new calculators, you can go alpha y equals enter, and a fraction pops up, and you just type it into the fraction. So are we getting a vertical asymptote at 3, negative 3? And negative 3, right? So it kind of shows us that we're right. And then is it curving at zeros? Yeah. Is the cow in opposite quadrants? Is it in what? Quadrant? 1 and 3, yeah. 1 and 3, yeah. Yep, I will in just 1 second. I want you guys to try this one out. I want you to give me the non-permissible values. Once you get the non-permissible values, you will have the vertical asymptotes, right? And then give me the horizontal asymptote, which in both cases could be different. So type it in and try and help yourself out. This first one for the horizontal asymptote, is this just a number over a variable? Nope. So see if you can maybe guess what it might be. And is this one a number over a variable? Second one? Yeah, so you can use your rules for horizontal asymptote stuff. So try these out. Do your NPVs. So my non-permissible value for this denominator, I take the 3x minus 1 off to the side, set it not equal to 0. I get 3x cannot equal 1. I get x cannot equal a third. Right? So that's going to be my vertical asymptote. My vertical asymptote is that x equals 1/3. Okay? Now, if I take the second one, I'm actually going to have to factor it. So I'm going to get 1 over x plus 3, x minus 3, because it's a difference of squares. Then I go off to the side and say x plus 3 cannot equal 0. X minus 3 cannot equal 0. So we're literally doing rationals. X cannot equal negative 3. X cannot equal 3. So my vertical asymptote is that x cannot equal plus or minus 3. So there's 2 of them. We'll type that one in and see what it looks like in a second. That one, the horizontal asymptote's easy. The numerator is a number, the bottom denominator has a variable in it, correct? So what's my horizontal asymptote for this one? Anyone remember?
0.
Yeah. Y equals 0. So it needs to have the variable, right? From those, we can get our domain and range really easily. Our range is just not equal to them, and so is our domain. So our range is going to be y such that y cannot equal 0, y-er. And our domain is going to be x such that x cannot equal plus or minus 3, x-er. Now if you type this one in, at negative 3, you're actually going to see a vertical asymptote. And at positive 3, you're going to see a vertical asymptote. And we have a horizontal running along here. But we have to make sure we type it in with the denominator in brackets, right? Or else it won't do it correctly. And then there's going to be a graph in there. Our problem with the first example is what? For horizontal asymptote. The top has a variable, and the bottom has a variable. They're both degree 1. So this one has an exponent 1, this one has an exponent 1, doesn't it? So it's not going to be y equals 0, because it doesn't follow my rule. My rule was the top has to be a number, the bottom has to be a variable, you get y equals 0, correct? This is the only second rule you're going to learn. This is it. There's 2 rules for horizontal asymptotes this year. It's going to change for next year, but this year, 2 rules. 1, numerator smaller than denominator, or numerator has a number and the denominator is a variable, it's y equals 0 every single time, no questions asked. 2, when the numerator and the denominator are the same degree, you just take a fraction of their coefficients. So what the heck does that mean? That means I just take the numbers in front of the x's. So these are both x to the 1. I take 2, I take 3, and my horizontal asymptote is 2/3. It's y equals 2/3. Right? Now the way I could make it a little bit trickier is I could go, I'm just going to show you this, you don't need to write it down, I'm just proving to you I can make it trickier. I could go y equals 1 minus 2x over 3x plus 1. So my vertical asymptote would still be -1/3, that wouldn't change. But my horizontal is the numbers in front of the x to the 1s. So some people will tell me it's 1/3. It's not 1/3. It would be -2/3. It's just the coefficients in front of the x to the 1s. So if I write it out of order, you just have to not fall to that error. Okay? It's just the coefficients. The numbers in front, they're called leading coefficients. So this is just a little summary that you can look back over if you want. We're going to flip over. So I want you guys to take 1 over x minus 2. I want you to give me the vertical asymptote, the horizontal asymptote, the domain and range, and then I want you to graph it. Right? How can we get coordinates for our graphs? Where's the fast way on our calculator? Second graph gets us the table of values. Or we can always go second trace value and put in any x and it'll give us any y, right? Second trace value. So you try out number 1. So if I go to my vertical asymptote, I would do my NPV off to the side. So I go x minus 2 cannot equal 0, x cannot equal 2. So my vertical asymptote is going to be at x equals 2. And my domain is going to be x such that x cannot equal 2, xdr. My numerator is a smaller degree than my denominator, meaning my numerator has a number, my denominator has a variable. So what is my horizontal asymptote going to be at? Y equals 0. So my range is going to be y such that y cannot equal 0, yer. So at x equals 2, which is a vertical asymptote, I have a dashed line. At y equals 0, I have a dashed line. Now I could plug in whatever I wanted to in here. This one would be a fast one, so I'm just going to do it that way. So if I wanted to, I could do my own xy table. I can plug in a 0, and I get 1 over 0 minus 2, so that would be -1/2. So I'm at 0 and -1/2. I could plug in 1, and then I would get 1 over 1 minus 2, which is -1. 1 and -1. I could plug in 2. I get 1 over 2 minus 2. Oh, that's 1 over 0, undefined. Oh, I just proved my asymptote is correct, right? I could plug in -1, and then I would get 1 over -1 minus 2, which is 1 over -3. I'm literally just plugging it in for x. I get 1 and -1/3. And this part's going to be over here like this, and it's going to curve along here. I could plug in 3. And I get 1 over 3 minus 2, which is 3 and 1. Plug in 4. And I get 1 over 4 minus 2, which is a half. So it's 4 and a half. And then I get running up here, running down here. So that'd be my sketch. Now this is a reciprocal function because it's 1 over a function, correct? In order for it to be reciprocal, it has to be 1 over. So if it was 2 over, it's not a reciprocal. If it's x plus 3 over x minus 2, it's not a reciprocal. It has to be 1 over to be a reciprocal, correct? 1 over makes a reciprocal. What was the original equation if this is a reciprocal? So it was 1 over the reciprocal is 1 over f of x, right? That's what reciprocal is. What would the original have been in this one? Y equals x minus 2. So my original is 1, y equals x minus 2, and then I ask you to find the reciprocal, we just do 1 over it. So when it's 1 over, that bottom equation is your reciprocal. Okay? So what would the original have been of this one? Y equals x plus 3 would have been my original in order for this to be a reciprocal. Is this a reciprocal? Oh, it's not 1 over. Is this a reciprocal? No, it's not 1 over. Is this a reciprocal? No, it's not 1 over. These are called rational graphs. They're called rationals. The only way it's a reciprocal is if it's 1 over. The rest are just rational graphs. They're not reciprocals. I can't say determine the reciprocal of x plus 4 if I have a 2x on the top. It has to be a 1 over just the function. That's what a reciprocal rule is. So these are rationals. They're not reciprocals. Okay? But we still follow the rules. So for these ones, I'm going to be nice. Don't sketch them. Don't care if you sketch them. We're going to ignore sketching for now because we're going to do more sketching tomorrow. All I want for these ones is vertical and horizontal asymptotes, domain range. Vertical, horizontal asymptotes, domain range. Vertical, horizontal. Just do that. Don't need to sketch. I'll be nice. This one, vertical asymptote, you should have gotten x equals -3 because that is the asymptote. How'd you do? Because that is the NPV. Of course, it's because it's the asymptote. That's what I did. That was stupid, what I just said. Anyways, the horizontal asymptote is what? Y equals 0 because my numerator is a number, my denominator is a variable, therefore the numerator is larger or smaller than the denominator. So it's y equals 0. My domain is going to be x such that x cannot equal -3, XER. And my range is y such that y cannot equal 0, YER. This one, my vertical asymptote, if I solve for this, x plus 4 cannot equal 0 if I get my NPVs, x cannot equal -4. My vertical asymptote is going to be x equals -4. What's my horizontal asymptote? Y equals what? Anyone know? 2 over 1. Because this is degree 1, so I take the coefficients. So it's 2 over 1, or I could just say 2. So my domain is x such that x cannot equal -4, XER. My range is y such that y cannot equal 2, YER. This one, my NPV is going to be x plus 1 cannot equal 0, x cannot equal -1. It's not a reciprocal function, it's a rational, because reciprocal has to be 1 over the function. So my vertical is x equals -1. My horizontal is y equals what? 1, because it's degree 1, I take the leading coefficients. 1 and 1. 1 divided by 1 is 1. So my domain is x such that x cannot equal -1, XER. My range is y such that y cannot equal 1, YER. This one, I take x minus 2 cannot equal 0. X cannot equal 2. My vertical asymptote is x equals 2. What's my horizontal? Y equals 0 because there's no variable in the numerator. The numerator is a smaller degree than the denominator. This one has no variable, this one has a variable. This would be degree 0, this would be degree 1. So it's y equals 0 every single time. X such that x cannot equal 2 XER. Y such that y cannot equal 0. Okay, flip over. All right. We're going to look through these we're going to reiterate our asymptote rules. So, no matter what, the vertical asymptote comes from the denominator, correct? The vertical asymptote comes from non-permissible values. That's always what's going to happen. That's never going to change. It's the horizontal asymptotes that change. So this one is technically x to the 0 and x to the 1. So my degree of my numerator is less than the degree of my denominator. This is smaller than this. That's what this is summing up. What I said to you is if the numerator has a number and the denominator does not have a number, it has a variable, the degree is smaller, right? It'd be x to 0, x to 1. Whenever that happens, explain y for number 1. Whenever this happens, we get y equals 0. So when our numerator is a smaller degree, we get a horizontal asymptote at y equals 0. The example above was f of x equals 1 over x minus 2. Explain why. So your numerator degree is less than your denominator degree. Number 2 has 2x, y equals 2x over 3x minus 1. So here it says if n is equal to m. So what does that mean? Same degree. In this case, this is a 1, this is a 1. This horizontal asymptote for this example would be y equals 2/3. But if I give a general example, so instead of having numbers, like y equals ax over bx minus c, if I give that, which 30-1 says a lot of variables, not numbers. If I gave you this, our vertical asymptote would still be from the denominator. So it would be bx minus c equals 0, bx equals c, x equals c over b. So it would be variables. It wouldn't be numbers. That's how 20-1 trumps to 30-1. Take out numbers to be variables. We need a question like this, and just say a, b, and c are the value of whole numbers. Value natural, it's not wholes, it could be zeros. Value natural numbers. And then your horizontal asymptote. Your horizontal asymptote would be just a over b. It's nothing crazy. It's not ridiculously hard. It's just different without not having numbers. It would still be your leading coefficients, a over b instead of 2 over 3, right? You don't overthink it. Your assignment are the questions below. So for homework, you have to do number 1 and 2. 1 and 2. Tomorrow we're going over drawing reciprocal graphs and absolute graphs. And then we do absolutes from normals, and then we do solving absolutes. So tomorrow we'll be done reciprocals. It's that fast. So you're doing numbers 1 and 2 for right now. I'll give you a few minutes. So the first one says state the equations of vertical and horizontal asymptotes. So the vertical comes from the denominator, so I do 5 minus x cannot equal 0. I can add my x over or subtract my 5, whatever you want. And x equals 5. So x can't equal. So my vertical asymptote is actually equal to always. My vertical asymptote is x equals 5. My horizontal asymptote is what? Y equals 0 because the numerator is a smaller degree than the denominator. The numerator has a number and the variable has a variable. The denominator is a variable. The variable is a variable. Losing my mind. Okay. I'm going to go VA and HA, but on test you have to write vertical asymptote and horizontal asymptote. In your notes you can write VA and HA. On test you cannot. Because you will have diplomas and they will not allow that. So this one, we have 7x minus 2 cannot equal 0. 7x cannot equal 2. X cannot equal 2 over 7. So on this, I can go HA, because it's my own notes, x equals 2 over 7. VA, numerator smaller than denominator, so y equals 0. I can do this, but on a test, I'm not allowed to use short form, because then you're assuming they know what the short form stands for when they're marking your diploma, and they may not for next year. So no short forms. They'll give you no marks. It really would suck. Okay, for this one, I have horizontal asymptotes, and I can short form because it's my notes. For this one, is that x equals -1. For this one, it's at -0.5, and I can just put a comma in between just like I did with asymptotes. Or what I did with NPVs. Vertical asymptote, my numerator is a smaller degree than my denominator. My numerator is not a variable, my denominators do. So it's going to be y equals 0. This one, I'm going to get horizontal asymptotes after I factor it at x equals -4 and 3. The 2 in front has no variable, so it wouldn't get me an NPV, which would not be a problem. Yep?
Vertical asymptote says x on the first one, and horizontal as x on the second one.
Ah, this is why you shouldn't short form, because you're stupid when you short form. When you're me. I know, it's been vicious. See, look at this. I carried it through. This is another reason why you shouldn't short form, because you suck when you short form. Ah. Good catch, bad mistake. HA, y equals 0. Yeah, and if you flip-flop them, you get no marks too, right? Because your asymptotes would be wrong. If I had done what I did, it would be bad. Bad news bears. This one, vertical, horizontal, domain, and range. So this one would have a vertical asymptote at x equals 3, a horizontal asymptote at y equals 0. My domain would be x such that x cannot equal 3, XER. My range would be y such that y cannot equal 0, YER. This one, I would have a vertical asymptote at x equals 1 and a horizontal asymptote. Don't pack up. You don't know if you did it right. 2 over 1, which is 2. Stop packing up. Don't even have papers out. The domain is x such that x cannot equal 1, XER. And the range is y such that y cannot equal 2, YER. This one, quiet please. Vertical asymptote, why is it 2?
Oh, never mind.
Fraction. X equals -2, horizontal asymptote. It's going to be 4 over 1, so y equals 4. Domain, x such that x cannot equal -2, XER. range. Then your homework is done for today. Please wipe off your desk.